So, as I am doing a series on the DevOps capstone project, I realized, maybe I should do a refresher on Docker and containers. So, this video will act as an introduction to containers and Docker. Hi, I'm Rishabh. This is rishabincloud. And today we'll be looking at what containers are and how we can utilize containers using Docker. So the first question I also want to address is Docker is really important in the DevOps space. And here's a really good survey. So Stack Overflow does these yearly surveys, and you can see that in developer tools, Docker is the most voted developer tool that is being used by professionals in the industry. So now that you know that Docker is really important, let's get into containers. So containers are lightweight standalone packages that contain everything needed to run a piece of software, including the code, runtime, system tools, library, and settings. And the key benefits or key points for containers are you get consistency across environments. They are resource efficient when compared to VMs, which were used traditionally, and you get isolation and security. So if we were to look at containers and VMs and differentiate between those, I do have this diagram, which I believe is from Atlassian. So here you can look at virtual machines, and this was the traditional way we used to host our applications or code. So you had your infrastructure, which is the hardware, you have the hypervisor, and on top of that, you had your virtual machines, which also included the guest OS itself. Now, with containers, the difference is you have your infrastructure, your host operating system, and then you have a container engine on top of it. This lets the containers to share the host OS kernel, which means that containers are lightweight because they don't have the guest OS. Now, if we look at the key differences, so virtualization is at the operating system level in containers, whereas with VMs, the virtualization was at the hardware level. Containers share the host OS kernel, whereas VMs run a full copy of an operating system. Containers are lightweight and start up quickly, whereas VMs are heavier and slow to start, which means that container consumes minimal resources, whereas VMs consume significant amount of your hardware resources, which makes containers ideal for microservices or microservice architecture. On the other hand, VMs are better for running multiple different OS types, if that's the use case. So the important point here is that the containers virtualize the OS while VMs virtualize the underlying hardware. This makes container more portable and efficient. So now that you know what containers are, let's talk about Docker. So Docker is a platform for developing, shipping, and running applications in container. So it helps us simplify the process of container management. And there are three important concepts within Docker. So you have your Dockerfile, you have Docker image, and you have containers. I also want to point out, if you're very new to containers and are a beginner with Docker, I have written this blog post called Understanding Docker as an 11-year-old. I'll link it down in the description. Do check it out. I do a comparison between Docker and Lego. I hope that analogy kind of solidifies what Docker is. So coming back to Docker, we talked about the three main components. The first one being Dockerfile, which is a script containing a series of instructions and command for building the Docker image. So what I have here is a fast API application. It's pretty basic. Let me zoom in. I think the code should be readable. But as you can see, Fast API is a framework or library that allows you to build APIs in Python. So what I'm doing is on top, I'm importing Fast API, and then I'm initializing Fast API as app. And we have a default route or the root route for our API. So if I go to the root URL for my application, I'll get this message. Similarly, we also have a route called /items. So what I can do is quickly show you how this works. Locally, dev app /main.py. I can also show you the directory structure while that gets running. So on the right-hand side, you can see I have an app directory within my root folder. And within that app directory, I have my main.py. And the entire code exists in the main.py. In the root directory, I also have requirements.txt that just contains the fast API. Underneath in my terminal, I do have a virtual environment already set up, and I have installed the required packages, which in our case is fast API. So as you can see in the terminal, it says the application startup complete. So let's go to 127, and port 8000 is where fast API runs by default. So you see, we do get the response as we try to access the root route in our API. Now, if I go to /items, you can see it responds with an item ID, and Q stands for query, which is null. So if I add a query parameter here, hello world, you can see that it returns the item ID, which was 1 set by us, and also the query hello world. So you get the idea of this basic fast application. Now, we were talking about Dockerfile, so let's come back to that. So as we learned, Dockerfile acts as a script to build your Docker image. And in order to create a Dockerfile, you basically just create a new file called dockerfile, as you can see here. So let's start creating our Docker file for our fast API application. So the first thing you have to do is pull a base image. So in our case, we'll be using Python image, and you can look up Python Docker images. So these are all the official images from Python. And again, this is dockerhub. I'll talk about it a bit later, but you can see there are different versions of Python images that are available. So let's go ahead and use 3.9. I believe that's what the fast API example uses. So from Python, and then you specify the version. So you can see I can also use Slim. This is Copilot suggesting me which image to use or which base image to use. Now we'll set a work directory. So this is within our container itself. So what this means is we'll be using /app as the work directory. Let's rename that to code. Now what we'll do is copy our requirements.txt. Again, this is Copilot suggesting, but I want this to be copied to the code directory itself within our container. So what we are doing is we are copying requirements.txt from the root of our project directory right now, and we are copying it to the code directory within our container. Now we'll run a command, and this command will install all the required dependencies. In our case, all of them are listed in requirements.txt. So the command is pip install -r requirements.txt. Again, we do have to include the path where the file is within the container. So in our case, it will be /code/requirements.txt. Now, locally, we have our main.py within the app directory. So let's copy that. So copy app, and we'll copy this to the code directory within our container. There we go. Now we have to run the command to start our fast API application, just like we did in our terminal. If I do Control-C and do an up arrow, you can see I ran the command fast API space dev space app /main.py. Similarly, we have to run a command in our container. So fast API, run, and this is in our app main.py is the file that we want to run. We can also specify the port that we want to use, and let's set it to port 8. And there are more arguments for the fast API command. You can look up the fast API documentation, but the focus of this video is Docker. So we have our Docker file ready. Let's hit Command S. And now within our terminal, let me make this bigger. Let's clear the screen. Let's make sure we are in our root directory. That's where the Docker file is. What I'll do is use the docker build command to build the Docker image. So if I go back to my docs here, you can see Dockerfile is used as a script to create a Docker container image. I believe I do have a diagram. So there we go. So we created the Docker file. Now we have to create a Docker image. And there is a command within the CLI. So if I do docker build, -t is an argument to tag the image. So we'll tag this as docker-fast API. And now if I do a period, which is where the Docker file is located. So if it was a different directory, I would have to specify the path. But since it's in the root and that's where we are running the command from, we can just put period and hit enter. So as you can see, I got an error saying that it cannot connect to the Docker daemon, which means I don't have Docker running on my laptop. It is installed. So let me go ahead and run the Docker daemon on my laptop here. Okay, as you can see, the Docker is running now. So this little whale icon is Docker's icon. So it is running right now. And if I do run the command again of building the image, you can see that it is doing a bunch of different steps to build the image. So the container image is built. Now we can use the docker run command to run this container image, and it'll give us back a running container. So in order to run, we'll type in docker run. We'll run it in detach mode, and you can do that by typing in -d or --detach. We'll name this my container. We'll also expose the port. And now we have to specify the image name, which is Docker Fast API. Hit enter, and this will give us back the container ID. So now if I do docker ps, which is the command to list the running containers, you can see that we have the Docker Fast API image running, and this is the container ID. So if we go to localhost, we should be greeted with that message which we had in our Fast API default route. There you go. So this is basic Fast API application. So if I go to /items, there we go. We got the item ID back as 1. And if we add a query, hello from container, there we go. So we have our Docker container running. So basically, we did all these 3 steps. We created the Docker file, which we used to create the Docker image, and then we used the Docker CLI to run that image as a container. So now you can build this kind of concept that the Docker file, is a script that we use to create container images. And once we have the image acts as a blueprint for creating the container itself. Now, moving on to Docker Hub. So we saw that with Python, we were using a public image, right? So within our Docker file, if I go back here, you can see we were using Python 3.9 as our base image. And this base image is available publicly along with all the different versions. So let's say if you were to use 3.13, which will be Python version 3.13, you can use any of these tags to pull those base images. But the fact they are publicly available, it has to be stored somewhere centrally, right? So in simpler terms, Docker Hub is just like GitHub, but for containers. So we use GitHub, right, to store our code repositories. Similarly, we use Docker as container repository. So it's a central place where you can store both private and public container images. So as you can see, I am already logged in, and I think it would be appropriate if we push our local image to Docker Hub. I think it's really important part of Docker, but you might not use Docker Hub maybe at your company, or they use ACR, which is Azure Container Registry, or ECR on AWS. I'm not sure what it's called for GCP, but probably Google Container Registry or GCR. And also GitHub has a container registry too. So Docker Hub is the popular one. We'll be using that today. So in order to push our image, now that we have it locally built, you will need to have a Docker Hub account, first of all, and you'll also have to authenticate your Docker Hub with your CLI. But once you have that, what you can do is type in Docker. Now we have to tag our image. So what I mean by that is if I go to my repositories, we'll have to create a new repository just like we would have done it in GitHub for our code. So for our container, let's name it Docker Fast API. This is Docker Fast API image. We'll click create. Now you can see we get a command on how to push our image from local to this container registry. So first of all, what we'll have to do is tag our locally built image. In order to tag, we'll use the docker tag command. So we called our local image Docker Fast API. We'll use the latest flag, and we'll tag this as the exact name we gave in our Docker Hub registry. So first you'll have your username, and then Docker Fast API, and we'll use the latest tag. So here you could also use something like version 0.1, and you can have incremental versions as you optimize your Docker images. But for me, I'm just going to use the latest for now. So now our locally image called Docker Fast API has been tagged as rishabkumar7/Docker Fast API latest. Now, what we can do basically is copy the command that Docker Hub gave us to push the image. So if I come back here, type in the command, make sure I update the tag name to latest. You can see since I'm authenticated, I'll start pushing the image to Docker Hub. So the push has been completed. So if I refresh my tab on Docker Hub, you can see that we have a latest image that is available. So now you can use this exact image by doing a Docker pull. So Docker pull is a command to pull publicly available images or private images if you're authenticated and you have proper authorization. Let's go back to the other tab here, and now you can kind of understand that Docker Hub is a cloud-based registry service that allows you to share container images with your team, customers, or the developer community. And we did see that there are publicly available images, but here are some of the important commands that I also want to go over. So we already saw Docker run, Docker PS in action, right? As I was telling, you can pull publicly available images through Docker pull. So one of the examples I want to do is with Nginx. So if we search for Nginx Docker image, we'll see this link to Docker Hub, and this is the Nginx official image. We just have to type docker pull Nginx. So let's do that. So in my terminal, I type docker pull Nginx. So it's going to use the default tag, which is latest, and it was able to pull the image from Docker Hub to my local laptop here. Now, I already showed you Docker PS, but let's stop our Docker Fast API container. So I can copy this container ID, do docker stop, and then the container ID. So if I do a Docker PS again, you'll see that we don't have the Docker Fast API container running. Now let's run the Nginx container, which we just pulled from Docker Hub. So docker run -d -p, and we'll use the AT-AT. We'll also name this as web Nginx container, and the image we'll use is Nginx. So now if you do docker ps, we should have our Nginx container running. Let's go to our local host. Oops, it's AT-AT. There we go. We have an Nginx server running via Docker as a container. So that covers up the most important aspects of Docker and containerization with Docker. I hope this video was kind of helpful. We covered quite a bit. So we covered what containers are and what advantages they have over traditional VMs. We also learned about Docker, what a Dockerfile is, what is a container image or Docker image, and what are containers. So Dockerfile acts as a script that you provide instructions to create a container image, and container image acts as a blueprint on which the container is built. Then we also learned about what Docker Hub is and how it's comparable to GitHub. And we also pulled Nginx, which is a publicly available Docker image, and ran it locally using the Docker CLI. So I hope you found the video helpful. I also would highly encourage to test out this image. Whatever you learned, go build your own Docker containers by creating a Dockerfile, creating an image, pushing it to dockerhub. And if you want to use, you can use mine. So as an exercise, you can do a Docker pull on rishabkumar7/docker-fast API and see if it runs. And yeah, I hope you find the video helpful, and I'll see you in the next one. Peace.